Alright guys, this is the second video that goes along with Tuesday/Wednesday. This is going to be on word problems with angle of elevation and depression. Now, I know you saw these in geometry, but it's been a while again. So just let's talk for a second about what angle of elevation is. Okay, so if we're talking about the angle of elevation, let's say from the ground to the sun, totally just making this up right here. Angle of elevation is going to be this angle right here, okay, from the ground. So angle of elevation goes up. Okay, angle of depression. Actually, let me do a new picture for this. Okay, angle of depression. Okay, let's say we're up on a mountain or a cliff, I don't know, and we're looking down at the ground. Okay, angle of depression is going to be this angle right here. So if you think back to your days of geometry, if assuming that this is parallel with the ground, the angle of depression is really going to be the same as the angle of elevation down here. Okay, so just keep that in mind. Angle of elevation is generally from the ground up, and angle of depression is from that horizontal line with the ground but down. Okay, so key thing here is going to be is that you need to be able to draw the pictures for the scenario. So an 80-foot rope is attached to the top of a vertical pole. So here's my vertical pole standing in the center of a circus tent. So think about how when you have the vertical pole in the middle of tents, they have the ropes coming out the side. So here's my 80-foot rope. Okay? The other end of the rope is attached to a stake 60 feet. So here's the stake. Think about how the stakes go into the ground. Okay, 60 feet from the base of the pole. So 60 feet. Pretend that lined up nicely. So this is a right angle right here. Determine the angle of elevation of the rope. So angle of elevation is always going to be down here with the ground. So that's the angle we're looking for. Okay, so think about what you have according to this angle. We have the adjacent side and the hypotenuse. So which trig function would go along with adjacent and hypotenuse? Cosine. So cosine theta equals adjacent over opposite. Please, once again, make sure your calculator is in degree mode. So we need to do cosine inverse of each side. And when you do that, you get 41.4 degrees. Okay? Like I said, the biggest part is being able to set up the picture. So this one takes it up a notch. Now, they started to set it up for you a little bit here. So a security camera is in a bank and it's mounted on the wall 6.2 feet above the level of the counter. So here's my counter. Okay? Now it's 6.2 feet above that. So if I go like this is 6.2 feet. Okay? And 9.4 feet behind the front edge of the counter. So this is the front edge. So this is 9.4 feet. What is the angle of depression? So remember, we would create this horizontal so that it's parallel with this guy. The angle of depression is going to be, if I draw this in, okay, if it's to be, let's keep reading, hold on. If it's to be aimed 2 feet beyond the front edge of the counter. So let's go 2 feet beyond the front edge. So we need an additional 2 feet here. So this is where the camera needs to be aimed. Okay, so we're aiming this here. This is the angle of depression. I didn't draw this very well. Sorry, guys. Let's do this. Sorry. Okay, so if you think about it, that's the same as this angle down here. So we need to find that angle. So if you take a look, this whole bottom side of this triangle, okay, is really 11.4 feet. So once again, we have the adjacent side, and actually, not once again, sorry, we have the opposite side. So that would be tangent. So tan theta equals opposite, so 6.2, over adjacent, 11.4. So if we do tan inverse of both sides, we will get 28.5 degrees. So let me back up one second, just because I was a little messed up there. So it's mounted 6.2 feet above the level of the counter. So here's the level of the counter, so this is 6.2 feet. 9.4 feet behind the front edge of the counter. So imagine if a banker's standing here, this is the front edge of the counter. So this is 9.4 feet. What is the angle of depression if the camera is to be aimed so it's pointing 2 feet beyond the front edge of the counter? Okay, so that's the 2 feet. So this whole edge is actually the 11.4. Okay? The angle of depression always comes from this like fake horizontal and is in here, which because of alternate interior angles with parallel lines would be the same as your angle of elevation down here. Okay? All right, one more. An observer on the 12th floor of a building determines that the angle of depression of the foot of a building across the street is 54.6 degrees. The angle of elevation to the top of the same building is 82.3 degrees. If the street is 80 feet wide, find the height of the observed building. So this is a little harder than what you're used to seeing. So here's my ground. So an observer's not at the top of the building. He's not at the bottom. He's somewhere in the middle here. So I'm just going to call this the 12th floor. Put it somewhere in the middle. Doesn't matter. Okay. So he determines that the angle of depression to the foot of a building across the street. So here's my other building. So the angle of depression, okay, if I drew in this fake horizontal line would be this angle, okay, is 54.6 degrees. Now, that same person, right, is now looking at the top of the building across the street. The angle of elevation, okay, pretend now that kind of like this is the ground, okay, so the angle of elevation here is 82.3 degrees. The street in between those two buildings is 80 feet wide. So if this street's 80 feet wide, this little horizontal that I drew in here is also 80 feet wide. Okay? And let's assume that horizontal is going to create some right angles here. They want the height of this building here. So we basically have to set up two different equations here. Okay, so I'm going to call this part x and this part y. Okay, so if I'm looking at the top part right now, focus on this right triangle right here. Okay, if I know this angle, according to this angle, this side's the opposite and this side would be the adjacent. So that would be tangent. Okay, so if I take tan of 82.3 degrees, make sure your calculator's in degrees, equals opposite over adjacent. Cross multiply, basically you're taking tan of 82.3 times 80 and you get 591.7 feet. Okay, so that's the x. Now let's do the same idea for the bottom. So according to this angle, this is my opposite and this is my adjacent again. So we're going to do another tan. So tan of 54.6 degrees equals the opposite's your y over 80. Multiply the tan of 54.6 times 80 and you should get 112.6 feet. So the total height of that building, add the x and y, okay, you get 704.3 feet. Okay. After this, you're going to do, we're skipping that last one. You're going to do some practice in this file, and don't forget there's this problem at the bottom here, and there are answer keys. I will, in my plan, list an order of what I would do these in, because some of them are harder than others. Okay? Please let me know if you have any questions about anything. Thanks, guys.